Okay, one of the important things that you need to be able to do is read information off the property tables. We all know that, right? And so sometimes what happens, though, when you're trying to find information off the tables is that it doesn't have exactly what you need, okay? And we may have to do either single or double interpolation, okay? Single interpolation is a lot easier. Double interpolation?
No,
single?
It's interpolation.
Interpolation, yes.
Like some kind of,
Yeah.
like,
It sounds like
medical problem.
it's a or it sounds like some crazy thing that it sounds a lot more complicated than it really is. Okay, interpolation is actually a really simple thing. It just sounds scary and complicated and complex, but it's not. Okay, so single linear interpolation. Let me give you this example. Let's say you're asked to calculate water at a pressure, I shouldn't have said atmospheric pressure, I don't know why I said that, scratch that out. At a pressure, because that's clear, I guess it could be atmospheric pressure if we're way up in the mountains. We're climbing Pikes Peak, it probably would be. So, but let's just say pressure of 65 kPa. All right, so let's say we got a pressure of 65 kPa, and we want to know the saturation temperature. All right, so I decided to pull out a little bit of the chart for you instead of having everybody look up the big chart. We know clearly that 65 kPa is not on this chart. It's somewhere between 50 kPa and 75 kPa, right? And we know then the saturation temperature is somewhere between these two values. Somewhere between 81.32 degrees Celsius and 91.76 degrees Celsius. Anyone want to venture a guess of what the saturation temperature is of water with 65 kPa? Just looking at it, just guess it. What do you think? 88.5? Why do you say 88? What made you go with 88?
10 degrees difference between the two.
Yes.
5 times 3.
Yeah, because you saw in your mind 65 is closer to 75 than it is to 50. So you know the answer is going to be closer to 91 than it is to 81, right? So halfway wouldn't make sense. 86 doesn't make sense, right? Because it's not half, it's got to be higher than 86. So you're probably going, maybe 87, 88, something like that, right? That's what we're doing. So I think all of us can interpolate in our heads a little bit, okay? That's all it is. It's just kind of a guesstimate. Oh, okay, it's kind of this much through here. Okay, well, I think we're all kind of interpreting a mathematical formality to it. Okay, now, before we get into actually doing it, let me just tell you as a side note, two things. One, most of your calculators have interpolation programs if you know how to use them. Okay, so I would highly, highly suggest that you use and learn your interpolation program in your calculator. Two, there's apps out there now. You can even do this on your phone. You know, there's an app for interpolation, I'm sure. Okay, I'm sure you can find some app out there that can do linear interpolation for you. Okay, so there's no reason to get all worried about having to do this in a test or quiz environment. Use a tool. Okay, use a tool. All right, but I want you to understand it too. So here's how I understand it. Instead of just giving you a formula and plugging and chugging, let me just show you how to understand this. It's actually really simple. All you have to do is go back to some old school algebra, stuff you learned like in 8th grade, 7th grade, stuff like that. Okay, or maybe earlier, I don't know. So when you do interpolation, basically what I want you to do is I want you to think of drawing a line. So let's do this here. Let's have this axis be kilopascals, and let's have the other axis be the saturation temperature, okay? Now it doesn't really matter where you put these lines. You can just kind of arbitrarily say, okay, 50 kilopascals is going to be here, 75 kilopascals is going to be there. You have to put the two that surround the value. Obviously, if you have 65, you choose 50 and 75 because one's lower, one's higher, okay? By the way, that's why it's called interpolation, because you're looking inside. If you looked outside, what's that called? Extrapolation. We're not doing that, though. That's more dangerous. Interpolation's much safer. Okay, so we got that. We got here 81.32 is our temperature, and that corresponds to a pressure of 50 kPa. And then up here, you got 91.76. That's a saturation temperature, which corresponds to 75 kPa. All right, so you got those 2 points like that. Now, we all know 2 points make a line, so let's make that line. And I'll fill in the points just so we can see them more clearly. Okay. All we're trying to do is figure out what's the saturation temperature for, let's say it's right here, 65. So you kind of dot that up, gets to this point, and then you can take it over. Like that, okay? And we're going to call this unknown value X, the unknown saturation temperature at a pressure of 65 kPa. Okay. All right. Then what I want to do is I want to show you one more line. I'm going to draw a blue line that goes from the first dot at 50 kPa up to this point there. Okay? Okay. Now we're going to apply a very simple grade school mathematical concept, and that is slope. Slope, okay? Now, I don't remember much about slope, but I overrun, right? And the key thing is to realize that the slope of the red line is the same as the slope of the blue line. They're the same line, same slope, right? And so here's what we're going to do. Let's write out an equation that represents the slope of the red line. Okay, look at the red line. It goes between the 50 and the 75 kPa, right? So what's its rise? How much does it go up? Well, it goes up a value of 91.76 minus 81.32. That's how much it goes up, right? And then what's its run? Well, it goes over 75 minus 50, right? That's its rise divided by its run. That's its slope. Okay. That slope is equal to the slope of the blue line. Okay? So what's the slope of the blue line? Well, what's its rise? Well, it goes up from 8132 up to x. So that would be x minus 8132. And its run is between 50 and 65. So it would be 65 minus 50. Okay? Now, once you recognize the two slopes are the same, you can simply solve for x by doing some algebra. Right? It's not that hard. You just write this out. You say, okay, 91.76 minus 81.32 divided by 75 minus 50 multiplied by 65 minus 50. You're going to add 81.32 if you figure it out, equals x. So all you have to do is just plug and chug that away. If you look, 87.58. Great. And that turns out to be the units of degrees Celsius. So interpolation is not too hard. It's just a matter of drawing this out. Draw the slopes. If you're ever stuck on a test, you need to do interpolation, and you don't have your calculator or your app or whatever to do it, just remember, draw it out. Draw the slope of each one, equate the two, solve for x. It's that simple. Don't make it more complicated than it is. Okay? Do that pretty easily. So that's the way we do it. By the way, is the relationship between temperature and pressure really linear? No. No, it's not linear. We're assuming it's linear, but if you assume something's linear over a small range, even if it's not linear, you're probably really close. Okay? You're probably really close. So, you're not going to be too far off here. Are there other ways to do interpolation? Yes. If you really want to get into it, you could do more stuff and more complicated formulas, but this is fine. This is fine. Don't make it any harder than it needs to be. Just linearly interpolate between the 2 points to get the value you need using this process. And again, use an app, use your calculator. I had a calculator way back that did that. I even programmed one that did that. It was really handy. Okay. Now, this one's a little harder. Double interpolation. Okay, it's like double jeopardy. So, double interpolation. Okay. You have double interpolation when you have two information and neither one fits on the chart. Okay. See, in single interpolation, you still had. All you had to do is interpolate between the one value. That's pretty simple. Okay. In double interpolation, you don't even have a chart for that value, and then you have to still interpolate. Okay. So let me give you an example here. I gave you another snippet of chart. This is superheated. So this is superheated water that's at a temperature of 750 degrees Celsius and a pressure of 2.75 megapascals. Okay? Notice you don't have a pressure table for 2.75 megapascals. And if you look at those temperatures, you don't have a temperature for 750 degrees Celsius. That's double interpolation. Okay? Double interpolation will need to happen. All right? So what happens with double interpolation is that you have to make a new table. You will need to build a new table of values at that pressure of 2.75 megapascals using the tables. So essentially, you use the tables to build another table, and then you interpolate on that table. Okay? That's double interpolation. Yeah, it's a little bit messy. Okay? Now, in this example, I have greatly simplified it because all the numbers will be halfway between the two boundaries. Okay? So I've greatly simplified it just so you see the concept. Both numbers are halfway. All right, so let's do it. Here's what we got. So again, temperature 750 degrees C, pressure 2.75 megapascals. All right, so what I'm going to do is I'm going to build a table for 2.75 megapascals. And what am I going to do? Well, by the way, I need the specific volume, and I didn't make this clear. This is the specific volume. It's the first column in each one of those tables. Specific volume. Okay? And so what I'm going to do is I'm going to give you the specific volume at 700 degrees Celsius and that pressure of 2.75 megapascals. How am I going to do it? What I'm going to do is I'm going to interpolate here and here. Okay? Because I have one pressure of 2.5 megapascals and the other one's 3. So if I interpolate between both of those at that 700 degrees Celsius temperature, I will get the specific volume at 2.75 megapascals, 700 degrees C. Now in this case, it's easy because, again, 2.75 is halfway between 2.5 and 3, right? So what's halfway between 0.17835 and 0.14841? All you have to do is add those two numbers I've got boxed in red and divide by 2. Somebody do that for me? Great, thank you. Now I need to also build the table for 800 degrees Celsius. So let me label this in blue. We're going to interpolate between those two values, 0.19722 and 0.16420. What's halfway between those two values? Great. 0.18071. Excellent. So what you've done, essentially, is you built another table. You built a table at pressure of 2.75 megapascals. So now you know the temperature at 700 and the temperature at 800 corresponding to the pressure you want. Now, in order to get the temperature of 750 degrees Celsius, you will interpolate this table. Now what you need to do is add up those two numbers and divide by 2. I don't know what the rest. I just know it's those two numbers. Okay. I don't know. It's 4 or 5. I'll round it up to 5. Whatever. Okay. So now I've got an estimate for a pressure of 2.75 megapascals, temperature 750 degrees Celsius. There's my estimate of specific volume, and that's meters cubed per kilogram. It's in between, right? In between 0.16338 and 0.018. It's halfway between these two numbers, right? But up there, well, it's certainly not between the two numbers at the higher pressure. You can easily kind of get lost in it and go, I don't know, but there's a lot of numbers there. You're staring at a bunch of numbers. But if you carefully build your new table by interpolating between the other two, then it's easy once you see these two to go to there. So, yeah. Yeah, double interpolation is not very clear. It's even when, I didn't even ask you guys to give me an estimate because you look at it all and go, I don't know, it's hard to do. So,